Hello class, these are our 2-5 notes, equations, and their graphs. So like an equation, a graph can show us the relationships between unknown quantities and also restraints. Did I say restraint? Because I meant constraint. So constraints. So like when we've got a limit on the amount of money we can spend, or like when we did the bus problem the other day, no matter what, we had to spend $200 on the bus. So a graph can show us the relationships between unknown quantities, and also it tells us about the constraints. So here is our example. Suppose we're buying beans and rice to feed a large gathering of people, and we plan to spend $120 on the two ingredients. Beans cost $2 a pound and rice costs 50 cents a pound. If X represents pounds of beans and Y represents pounds of rice, write an equation that could model the constraints in the situation. So whenever we read a word problem, we really want to make sure that we understand what's going on. And so sometimes visualizing what's happening and kind of telling yourself a story about it helps us to make sense. So when I read this, I think about having like maybe tons of friends and family over. Everybody likes beans and rice. Vegans can eat it, vegetarians can eat it, people that have gluten allergies can eat it, right? It's a great thing to feed lots of people. $120 sounds like a lot of money, but beans and rice are pretty cheap. We could probably feed 50 people for that, right? So I'm imagining this big party, and then I'm imagining shopping for it. So when I go shopping, I'm going to have some stuff I'm going to spend money on, right? I'm going to spend money on beans, and I'm going to spend money on rice. So I know I'm going to have to figure out my cost of my beans, and then I'm going to have my cost of all that rice I'm going to buy. And when I add those two costs together, I'm going to get my total, right? I'll get my total cost. So reading through this, I know that my beans are $2 a pound, and X represents pounds of beans. So if I buy 5 pounds, 5 times 2 would be $10. So I have to take my X and I have to multiply it by 2 to figure out the cost. So my cost of the beans is going to be 2X. Then I've got to figure out my cost of rice. So my rice is 50 cents a pound, and I want to buy Y pounds of it. So same thing, I'm going to have to multiply. So I'm going to have to multiply my cost per pound times my number of pounds. So 0.50Y. And then my total amount of money I can spend, that constraint says $120 exactly. So the graph of, the graph of 2X plus 0.5Y equals 120 shows a straight line. Each point on the line is a pair of X and Y values that make the equation true and is thus a solution. It is also a pair of values that satisfy the constraints in the situation. So remember we talked about the constraints. I think the most obvious one is the $120 that we need to spend. So now we're going to go ahead and prove some different points are on the line. So remember when we're proving that we're proving that the following point on the line is a solution. So when we prove that they're a solution, we're using this equation and we're showing basically that ordered pair works in this equation. So we're basically doing kind of an answer check. We're showing equality. So wrong numbers here. I know on your paper that you have, we have 10, 200. I just never updated it on this. And that's for this point right here. So we're looking at this point first. That's 10, 200. So with ordered pairs, they're in alphabetical order. My X is first and then my Y. So again, I'm substituting into this equation. So I want to do 2 times 10 plus, and then 0.5 times my Y, which is 200. And then I'm checking to see this is actually equal 120. So this is what I'm trying to prove. So I'm showing equality. So on the right-hand side, I just have one number. On the left-hand side, I have a bunch of things that I need to simplify. So first I want to multiply. 2 times 10 is 20. And then when I'm multiplying by 0.5, it might help to think of the 0.5 as half. So 0.5 times 200 is 1/2 of 200. So I can think of this as half of 200. So half of 200 is 100. And when I add those together, it is going to equal 120 is going to equal 120. We often put like a little check mark next to it to show it we checked and it's true. So on the next one, I have an x that's 60 and a y that's 0. So that's going to be 2 times 60 plus 0.5 times 0 equals 120. Have it really work to squeeze this in the box. 2 times 60 is 120. 0.5 times 0 is just 0. And so we have equality again. 120 equals 120. And this point was right here, 60, 0. So it was another point on my line. This point, if we kind of look at this and think about it, this is kind of like my x-axis, or it really is my x-axis right here. It just says pounds of beans axis. But that point is really an x-intercept. Because my y is equal to 0, it's a point right on that line. So it is also an x-intercept. So that's just something we'll do more with over the next few days. So my last ordered pair that I'm checking, x is 45, y is 60. So 2 times 45 plus 0.5 times 60. Does that equal 120? That's what we're trying to check here. So 2 times 45 is 90. Remember when we do anything with the 0.5 like that, we're thinking of it as half, because 0.5 is 1/2. So half of 60 is a way to think that out without having to do to really do much math, right? Half of 60, we know that that's going to be 30. And so we're going to go ahead and add, and we get 120 equals 120. And this was another point on our line. This was the point right here. So remember, we wrote down in our little paragraph here, each point on the line is a pair of x and y values that make the solution true and are a solution. So this would be a solution right here. This would be a solution right here. I could go through this line and I would come up with lots of different solutions. So for the next two, we're going to be looking at points that are not on the line. So we want to see what's happening there. Investigate the following points. So I'm going to write my equation kind of here so I have it to look at again. So remember, my equation is 2x plus 0.5y equals 120. And now we're going to check points that are not on the line. So it makes us wonder, like, this is lots of different x and y value combinations. Does any combination work? So we'll go ahead and try 2 times 20 plus 0.5, or 1/2 of 80. And see, does that equal 120? So 2 times 20 is 40, and half of 80 is also 40. So this is definitely not going to be equal. And if I think about comparing 80 and 120, we think back to inequalities in alligators. The alligator would want to eat the 120, so this is a less than sign. Less than signs you can make with your left hand. And so 80 is less than 120 is what I'm writing here. So what I would like you to notice about this point on my graph is if I look at the point, and I started out with 2080. So let's just scroll up here and look at what's going on. It is not wanting to let me scroll. Maybe we can do it now. So if you look at that point here on my graph, if I look at the point 2080, it is a point below my line. So I ended up with something less than the 120, and it was a point below my line. Okay, so point is below the line. And that is significant. We'll do more with that later also. All right, for the next one, my 70 is my x, 180 is my y. So 2 times 70 plus 0.5 times 180, which is 1/2 of 80, equals 120. So we're checking this one now. So 2 times 70 is 140. 1/2 of 80 is 90. So I end up with 230, definitely not equal, right? So I'm comparing 230 and 120. So this one I'm going to use a greater than symbol because 230 is greater than 120. So that's what symbol I'm using. And if I look at this point, if I look at 7180, 7180 is a point right here. So this point is above my line. This one was below, this one was above. So you might have guessed that that's how it was going to work out. So when I found that cost, it was greater than the amount I have to spend, the 120. And so the point was above my line. Above the line. As always, make sure you get help during class if you need it.